So here we're going to go through some revision notes for EDEXCEL-Math Cambridge IGCSE for topic 6, 7, 8, 9. And we're going to complete the foundation part of EDEXCEL-Math for examinations in 2024 and 2025. Let's begin. So we're going to start off with topic 6. And to start off with topic 6, we have to understand the symbols, inequality symbols, or equality and inequality symbols. This is like a review from like grade 4 or something. This is a equal sign, not equal sign is the equal sign with a dash, greater than, moving to the right, less than, moving to the left, greater than or equal to, with a line, less than or equal to, with a line. Okay. Sets. So this is something new. Sets. Sets is a collection of elements, alright? Sets is a collection of elements. Elements, what can elements be? Elements is any number, any letter, any symbol. Or it can be letters, numbers, symbols, it can be objects. They are usually shown in curly brackets and they're separated by commas. For example, vowels. Vowels, what are the vowels? A, E, I, O, U. So these are all letters separated by commas inside curly brackets. So it's elements. Elements are numbers, letters, or symbols. They're shown in curly brackets and they're separated by commas. Elements use dots when the number of elements is too large. So for example, even numbers, we have an infinite amount of even numbers. But of course, we cannot write all the even numbers, so we usually write dots. 2, 4, 6, 8, dot, 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 to continue onwards. Universal set. Universal set means the set of everything. A set that contains different sets, which contains different elements. So universal set is one set. This one set has many sets inside it. And these individual sets have different elements inside them. For example, the universal set, by the way, this is the symbol for universal set. It's like an E with extended from the top. So for example, here, the universal set is 1, 2, 3, 4, 5, 6, 7, 8. This is our universal set. Our set A inside this universal set is even numbers, set B is odd numbers, and set C is multiples of 3. So we take all the even numbers and put them in set A. These are the elements of set A, 2, 4, 6, 8, 10. Elements of set B, 1, 3, 5, 7, 9. Elements of set C, 3, 6, 9. So in this example, we have 1 to 8 numbers, which is the universal set. From these, we extracted even numbers, odd numbers, and multiples of 3. These are the individual sets. And in each of these sets, we have the singular elements. Venn diagrams is a way to illustrate all elements inside sets and any notations between them. So the structure of a Venn diagram, you have a rectangle that represents the universal set, the big set, and inside this rectangle, we have a circle for each set, which contains different elements. So the circles may or not be overlapping depending on which elements are shared between them. So we're gonna now have a look at some sets and elements and how they are used by Venn diagrams. The shaded areas for each notation rule represents which elements are to be chosen for that particular set. So in this notation rule, the first one, A and B. This sign stands for and. So A and B means A intersects B. This means we have only the common elements between A and B. So this is the part we're going to choose from. A union B or A or B. This one means or. This means A union B, A and B together. Union means to join. So everything in A and B. So for example, we have you have Venn diagram here, 2, 4, 6, 8, 10, 12. If we have A and B, you're just going to choose 2 and 4 because only the shaded part in between, the common part. If you have A or B, you're going to choose everything. You're going to choose all the numbers because it's A union B, A and B together. This small apostrophe sign means not A, so everything except A. You choose everything outside A. A and not B, A and not B. So just the A part without B. The De Morgan rule. The De Morgan rule states that A and B all not is equal to A not union B not. So A not and union B not, A and union B is everything A and B, the shared part. So we cancel out the shared part, everything except the common between A and B. Because A and B is this part, A and B not is canceling out this part. So we choose everything outside. The opposite applies here. A union B all not is equal to A not and B not. Here, A union B not is everything outside A and B, and A union B, which is this part, is not, so it's not chosen. So everything between A and B all. This sign means belong to, this sign means not belong to. So a cross on it means not belong to. Usually we use these when one set belongs to another set or one set belongs to the universal set. N, A. When there's N and then brackets the set name, this means number of elements in set A. For example, R is 10, 12, 14, 18, 20, 22, 24. S is 9, 12, 15, 18, 21, 24. T is 10, 20. So number of elements in R is 8. 1, 2, 3, 4, 5, 6, 7, 8. Number of elements is T is 2, and so on and so forth. A fact to consider here that if all elements of set X and set Z, then X is a subset of C. This means X belongs to Z. And with that, we have covered topic 6, coming to topic 7, ratios. So this was about ratios and numbers. Ratio is a way of comparing sizes of two or more quantities. For example, 5 to 20 ratio, which can be simplified to 1 to 4 ratio if you divide both sides by 5. So if the ratios have different units, you always convert them to the same unit to simplify them. For example, 125 grams to 2 kilograms. To simplify this, we must have both in the same unit, so we convert 2 kilograms to 2,000 grams, and then we can simplify these. To make the ratios in simplest form, you must divide each by a common factor. 25 minutes to 1 hour, make sure it's the same unit. 1 hour, 60 minutes, 25 minutes to 60 minutes, divide both by 5. Ratio is 5 to 12. Ratios as fractions. 8 slices of pizza shared in 62 ratio. So you have 8 slices in total shared in 62 ratio. So 6 of 8 of pizza and 2 of 8 of pizza. 6 over 8 is 3 over 4. 2 over 8 is 1 over 4. And this brings us to dividing given ratios. So to divide given ratios, we have a formula. This formula is amount divided by total part times the separate part. For example, divide $250 between A and B in 3 to 2 ratio. Our amount here is $250. Our total part is 3 plus 2, which is 5. Our separate parts is 3 and 2. A takes 3, B takes 2. Now let's plot the given. Amount is $250. Part total is P1 plus P2, which is 5. Divide between A and B. So 250 divided by 5 times 3 is 150. 250 divided by 5 times 2 is 100. Another example, divide with 2100 between A and B in 3 to 4 ratio, 3 to 4. Our total part is 7. Our amount is 2100. So 2100 divided by 7 times the separate parts. So times 3 times 4 times 3, 900 times 4, 1200. Divide between A and B. If B is equal to 2800, find A with 3 to 7. So in this case, we divide by part total of 7 because the total amount is for B, not A. In this case, A is equal to 2800 divided by 7 times 3, and the answer. Now this is a bit tricky one. The ratio between boys and girls is 3 to 7. If the difference between them is 84, find the number of boys, girls, and total. So instead of taking the total part by adding, they give us the difference. So instead of adding, we're going to be subtracting here. So the difference is 7 minus 3, which is 4. This is our total part here. So the amount is 84 divided by the total part, which is 4 times 3 times 7 times 10. Multiply by all of them by the separate parts to get your answers. To find the unknown ratio variable, you can always use the cross-track method or the crazy Z method, which tells us you multiply the value above your unknown with the 1 beside the unknown and divide it above. So 3 times 5 divided by 2. Map scale. The rules for map scale is very simple, that in a map scale it's a 1 to n ratio where both must always be in centimeters or both must always be in the same unit. To convert from centimeter to meter, you divide by 100. Meter to kilometer, divide by 1000. Kilometer to meter, multiply by 1000. Meter to centimeter, multiply by 100. Or if you want to do it in one go, centimeter to kilometer, divide by 100,000. Kilometer to meter, centimeters, multiply by 100,000. And now let's jump into a quick overview on physics, because this is also included in our lesson. We're just going to understand some quick formulas here for speed, pressure, and density. Speed is distance over time. Distance is speed times time, as time is distance divided by speed. Density and pressure. Density is mass over volume. Mass is density times volume. Volume is mass divided by density. Pressure. Pressure is force per unit area. Area is force per unit pressure. And force is pressure times area. Proportion. Proportion is how two variables are related to each other. It can be directly proportional or inversely proportional. Directly proportional means as one variable is going up, the other one increases by the same rate. Inversely is when other one goes up, the other one goes down by the same rate. To calculate directly proportional, we use the cross-track multiplication or the crazy Z method we discussed above. As for inversely proportional, we use horizontal Z multiplication. It's just like doing the cross-track multiplication, but from up to down rather from down to up. So 5 to 20, 7 to x, find x. 20 times 7 divided by 5, crazy Z. 20 times 7 divided by 5. Here, 4 times 12 divided by 6. Up to down, here down to up. Easy as that. So directly you always multiply both by the same scale factor. Inversely, multiply one quantity by the scale factor, will divide the other one by the same scale factor, because as one is going up, the other one is coming down. And the unitary method tells us that the two quantities are divided by the same scale factor. So if you have 6 cars, and which is equal to 108 kilos, then one car is 108 divided by 6, 18 kilo. Coming on to chapter 9. For chapter 9, it's about index and powers and rounding and bounds. So index, what do you mean by index? Index is the power of 10. The word index means power of 10. 100 is 10 times 10, 10 to the power of 2. 1000, 10 times 10, 10 times to the power of 3, and so on and so forth. Standard form is a way of writing large and small numbers using index. Okay, using the power of 10. We have a formula for this, or a rule. X times 10 to the power of n, where x must be a number between 1 and 10, always. N must be always a positive or negative whole number. So for example, 3.2 times 10 to the power of 5, whole number, good. Between 1 and 10, good, it's in standard form. 16.2 times 10 to the power of 7, 7, good. 16.2, greater than 10. What do we do now? To change this, we move the decimal place 1 unit back, and we add 1 to the power. Now it's in standard form. So the rule is to make a standard form, move decimal 1 place back, and increase the power by 1 if it's greater than 10. To convert between ordinary form and standard form, for standard to ordinary form, you can always use a calculator. Just type in your number and press equal. To convert from ordinary to standard form, you must always use 3 significant figures. Press Shift and Mod, set to scientific mode, change the number of significant figures to 3, input your ordinary number, and press equal. Operations with standard form. To multiply and divide, you just multiply the common factors together, and when you're multiplying powers, you add the powers. When you're dividing powers, you subtract the powers. So here, common 9.2 times 3.1 is this much, this times this is this much. What do we do now? It's greater than 10. Well, you move the decimal place 1 place back, and you add 1 to the power. So it's 2.852 times 10 to the power of 12. In division, like I said, when you're dividing powers, you subtract the powers. So 7 minus 3, 4. Divide the common ones. Here it is less than 1, so you move the decimal place 1 place forward, and you subtract 1 from the power. So it's 5 times 10 to the power of 3. For addition and subtraction with standard form, you can always take out the common power and isolate by using distributive property. Then multiply the common numbers together. 2 times 10 plus 3.7 is 24.7 times 10 to the power of 4. Since it's greater than 10, we move the decimal place 1 place back and add 1 to the power. This is 2.47 times 10 to the power of 5. Last part for this video is rounding whole numbers. The rule is very simple. If the last digit is 5 or more, round up. If the last digit is 4 or less, round down. 25 to 29 will be rounded up. 24 to 21 will be rounded down. To round decimal places is, what is a decimal place? Is the number of digits right after decimal points. So this is a 1 decimal place number, this is a 2 decimal place number, this is a 3 decimal place number. So to round something, for example, for this number, to round it to this 2 decimal places, first identify the digit that's 2 places from the decimal point. This is your last digit. Look at the decider, the digit after the last digit, to decide whether round up or down. If the decider is 4 or less, leave the last digit as it is and eliminate all digits after the last digit. If the decider is 5 or more, round up the last digit and eliminate all digits after the last digit. In this case, our last digit is 1, is 2 places away from the decimal point. The decider is 7 and is greater than 5, so you round it up and eliminate all digits afterwards, so it's going to be 8.32. This is the same example repeated here. Significant figures is the first non-zero digit from left to right. So for example, in this 3, 4, 7, 6, this is significant 1, significant 2, significant 3. In this number, this is significant 1 because it's the first non-zero digit. Then this is significant 2, 3, 4, and onwards. So the first non-zero digit is a significant figure. To round significant figures, for example, round this number to significant figures. First, identify the second significant figure and make it the last digit. This number will round up or down. The next digit after the last digit is, as you know, the decider, and the same rule applies. If the decider is 5 or more, you round it up and eliminate all to 0. If the decider is 4 or less, you keep the last digit the same and cancel everything afterwards. For example, for this number, this is the decider. It is less than 5, so you eliminate everything afterwards, and 2.7.6 is your answer. Approximation of calculation by using estimation. Estimation is when we round each digit to one significant figure value before performing any order of operation. Examples: to multiply these two numbers by estimation, we round each number to one significant figure. This will round to 40, this will round to 7. Now you make the operation and your answer is 280. Bounds. Bounds is the smallest lower bound and largest upper bound a number can lie in between. It could have been rounded up or rounded down before. So it's simply how high or low a number could have been before it was rounded. This can be to the nearest whole number or nearest significant figure. To the nearest whole number, it depends on the range of the nearest whole tenth place. So if you're rounding to the nearest whole number, you add or minus 0.5, 190.5, and 200.5. Nearest 10 plus minus 5, 195, 205. Nearest 100 plus minus 50, 150, 250. Nearest one decimal place plus minus 0.05, 3.05, 3.15. If we're doing significant figures, then to the nearest significant figure, 0.5 plus minus if it's a single digit. If it's a digit in the 10th place, plus minus 5. So 70 will be 65, 75. If it's a digit in the 100th, plus minus 50. So 700 will be 650 and 750. And that is it for topic 6, 7, 8, and 9 for Edexcel Math Cambridge IGCSE.